So this is an example of an application of an integration problem, specifically for work. So the problem reads, on a 120-foot long rope with a weight of 5 pounds per foot hangs over a 200-foot high bridge. And we're just going to be answering part A, which is how much work is required to lift the rope to the top of the bridge. So as you can see, I'm drawing a figure of the problem just so we can visualize exactly what's going on. Very slowly drawing the bridge. And the only important piece of information concerning the height of the bridge is that it is taller than the rope, meaning that none of the rope is already touching the ground, and that's really the only part that's important. So it could even be 121 feet, it wouldn't matter, just as long as the rope's not touching the ground, which would change the formula for the problem. And I'm just labeling my rope and bridge. So as we know, work equals force times displacement, and we're trying to find the force in one section of the rope, which is the change in x, and that would be the change of x times the 5 pounds per foot. And we're just looking at this one segment of rope and where it is displaced. That gives us force. D equals displacement or distance, and D would also be equal to x. And now we're just writing out how we can approximate the total work done in moving the object from A to B as the limit of this quantity as n approaches infinity. So now we are going to integrate the problem from 120, or 0 to 120, and plug in the variables that we already have. And when we do this, we get 5 over 2 times x squared from 0 to 120. And further, whenever we actually plug in our values, b and a, so b minus a, minus 5 over 2 times 0 squared, which we all know this equals 0. So now we're just solving. Pull out the handy dandy calculator, plug in our values, and our answer is 36,000. All that's left is to write it down. Great work.